All right. So network analysis. This is like something you need to know that we pretty much we optimize a certain social science problem. Mainly, we link with that certain uh, issues in order to minimize the cost, the time, right? So to make a more efficient workflow in the your working environment. Okay, so network is one of the way to make the simplify our daily life problems. Okay, in order to optimize the works that what we carry out. Okay, so it's what we're going to discuss today. And specifically, we will discuss on shortest path problem. Okay, the shortest path problem, which means you're going to analyze the systematic approach in the network model in order to look for the shortest, I mean easiest path, or maybe the more optimized path uh, to as a solution of the given problem. Okay, so here we go. First, we're going to discuss about all of that introduction of the network. Then later we go in deeper. We look for the definition, the terminology we use in that network, the shortest path problems. Then we will look into the few real life applications, how we're going to incorporate the shortest path or network model into the daily life problems in order to find a optimized solution. Okay, so here we go. So these chapters, we will discuss about the network analysis. Okay, we will look for the network analysis, right? And then the network model, and then a network notation and the terminologies. Then we will look into the application of the shortest path problem. All right. So these are mainly the content we're going to look for today lecture, and we will go into detail. Okay. All right. So basically, if you can see that network analysis, so we call that is a systematic study, all right, of that which interconnected system, which is represented as a graph. Okay. So if you can see that this we basically we call as the network model. How does it look like? Okay, it's a connected to one to another by the age, all right, and based on the given entities, or we call as the nodes. Okay, it's all we call as a nodes. Okay, so basically the network model graph is look like some a complex model is something the given the forms of the representation, which is we call this all we call a nodes. Okay, we call node. Okay, this all called node. Okay, this is we call ages. Okay, ages, all right. And then in certain arrows which is just followed, we call is that is a path. Okay, we go in detail later in a while. Okay, so the graph contains the nodes, okay, and the edges, which is we connecting in order to see that the relationship between the nodes, okay, by connection made by the edges by using the line. All right, why this the network analysis is important? Okay, if you could see that the network analysis one of the essential part in the social studies, especially in when we come to design our network model. So it will make our daily life activity way easier, and in order to give that a better or efficient solution to solve any type of problems. Okay, as you can see that this network analysis come under topics of combinatory. Okay, combinatory is something. It's a one of the chapters come under in a pure science, pure mathematics. So I'm not going to give you the detailed explanation because when I was in the science, so it's back to each every theorems, proof, and so on. So since we are more okay, this is how it's application section. So I'm not going to touch anything on the very fundamental, the proving and theorem and so on. All right. I just want to see that the teach you how we're going to use this concept, which is network model developed, okay, in order to apply like into your daily life, okay, application or daily life problems. Okay, so start from 1, 2. So that will give you the and then you just go better pictures, the directed, right? Okay, you see the and arrow deep understanding, the directed and graph. So you're just moving towards 1, 2 or 1, 4, okay, 1, 3. So all right, this so is one of them, right? We call as a network model. Area is the most. We go more on complex. Is involved. All right, is to look like this. All right. First is under social science. Even more complex. So under social science, usually one of the analyzing that networks to understand the relationship, how it is all the networks. So when we just want to another science studies, say we just carry out points, some activities. So you can see the even more complex the humans, data, but right when you come to more how that then usually we use that Python. Okay, or carry from okay, so in order to analyze the more other people's network, and we see the for your fun how it's the fundamental knowledge another to implementation. Okay, so this is something like essential. So you need to know that everything from the ground. Otherwise, you cannot develop even that later we're going to do analysis on. Okay, so that's the main idea. CPM, okay, critical path analysis and so on. So you will know that the systematic. Okay, when we come to that, all this model networks, so you need to know the some terminologies can be used in order to that make a better solution. First of all, we solve the problems. Okay. Okay. The social science I said earlier, and then is we also present the transportation planning, the blue. Okay, to study. We call on notes. Okay, to present some books they refer as a vertex and represent using as a vertex network. Okay, model. And in order to study the traffic flows and optimizing the routes, or okay, for example, in the city, okay, so not and so on. Okay, okay, so it's also very helpful in the transportation planning. Okay, H further, which means if you look another term of ARC, okay, we cover the ARC later in a while. For next, okay, for example, company. The arcs means continue to navigate the complex. Say global market is node 1, okay, is node 2. So we'll see that okay, the arc will be written as product from 1 to. Okay, this is what this dispatch from one to another places, and when it export to another country, and how the route is just carried out. The product, the line here till to that and the circle here is for the final destination. So this is okay. So we see that the whole entire pictures, the line we call it just find that what are sort of the optimal the link, routes that we can carry out. You need to know in order to minimize the cost of the transportation. So, as well the logistic, the things which is we send off. So it's also like one of the essential part in the logistic and industrial logistic. So we use the network models. Okay, so mainly it's the process will be smooth and effective operation. Okay, it's mainly we just look into it. So it's importance in the industrial logistic. And then the supply chain management, same things. Okay, so in supply chain management, it will provide the valuable insight into the relationship. Okay, so you will see that based on that activities that we carry out, so you can see that the relationship, okay, how the supply chain management is involved, and then dependencies as well as the dynamic, okay, within the complex system. So you see the supply chain when you just involve is very complex, environment, working environment. So it's easy for us. We represent that the supply chains problems or activities, you convert into the network model, and then we just represent all the data that we have. Okay, so these are the main. Okay, there is more. I just give you some of examples. Okay, so that you can easily capture the idea where the network model is being applied. Okay, let's see some of the network model. Okay, for example, you can see that the network model is a very simple network model. Okay, so this is something based on the production, based on the customers. Okay, they make the order. So we can say, for example, we just take the example in the Shopee. Okay, eBay. What else? Lazada. Okay, how it is works. We can represent that all the process of buying things through the online. So we can able to express in the form of network model. So first, we are the customer, all right? We make the order through that some platforms. For example, maybe you can say the eBay, all right? So once we just make we order it through the eBay, so the order will be go to the order line, okay? So we go to order line. So the product, okay, so which is already available in that the platforms, okay, it is will be included into the order line, and then the shipment is made, okay, the shipments will be made to that the order line, and then you can continue. So the shipment is processed, and then you will receive that the buyer or customer. So it's back to again to that the loop, okay, to the customers. Okay, this is how it's happened. Okay, it's a network model. This is one of the very basic network model. All right. Sometimes you could see that the network model is a bit, developed. Okay, more extreme, intermediate, like more on complex words. Okay, so it will look like this. Okay, so start from 1, 2. All right. So and then it just goes. You see the directed. Okay, you see the arrow is come out. It means the directed graph. So you're just moving towards 1, 2 or 1, 4. Okay, 1, 3. So this is one of them. All right, we call as a network model. If we go more on complex, all right, it will look like this. All right, so it's maybe it's more even more complex. Okay, just one of the complex networks. Okay, if you could see how it is, all the network is connected one to another from that each node points. Okay, so even you can see the even more complex data, but when you come to more complex data, then usually we use that the Python. Okay, so in order to analyze the more complex network analysis, but for your fun work, the fundamental knowledge of the implementations, the network model is essential. So you need to know that everything from the ground. Otherwise, you cannot develop that network model into programming. Okay, so that's the main idea, all you need to know. Okay, all right. Okay, when we come to the network model, so you need to know the some terminologies we use in that network model. Okay, first of all, we need to know the nodes. Okay, so I said earlier, the node is which is present the blue circle here, the blue dot circle here. This we call a nodes. Okay, and some books they refer as a vertex. Okay, they also call as a vertex. Okay, and it can be thought as one of the location or stop. Okay, so the node points. Okay, remember. All right, H. Okay, H, which means the another term of arc. Okay, we cover the arc later in a while for next step. The arcs means usually they give you that say for example this node 1, this node 2. Okay, the arc will be written as this form 1, 2. Okay, this is what they call as an arc. Okay, arc. Okay, so this H is connection. Okay, the vertices, the line here and the circle here is connection. So this is we call as a the line we call as a edge or link. Okay, the link. So that is the terms you need to know. Moving on. So once you just identify that the nodes, right, and H, all right. Next, moving on the arcs. As I said earlier, right, arcs. Okay, the arcs is called an H or represent the connection between the two nodes. Okay, so this is the as what I said just now, right? So AB. Okay, so this is a connection between the two nodes. Okay, and it has a direction. So remember, so usually when we say the AB, so this is a vector which is A to B, so which is A to B. So usually we do not denote this line, the vector form. We just mention as a AB, which means is moving from the precedence is A and end up is a B. Okay, and it has a direction with the arrow. Okay, direction to arrow. So A to B. All right, and is as a weight. So weight means this is what we call weight. Okay, they said A to B is a, say for example, is a 4 kilometers. So the 4 is it's a weight. Remember. Okay, this is what we call a weight. Okay, and it can represent the distance. Okay, the weight is can be represent the distance, time, cost, for, and then any other metric associated with the transversing of the connection. Okay, so it's like the B to D or D to F. Okay, E to D. All right, so that's what we call is all the arcs. Okay, E, D. Okay, look at that, the directions. Okay, okay, look at the directions, the arcs. Okay, so the given usually in this forms. Okay, remember the arcs. Okay, so now we know that node, edge, and then arcs. Okay, moving on. Further, we need to know that another terms we call is path. Okay, path. So path, which means the chain. Okay, the path is a chain where the weight of the arcs are minimized. Okay, so in other words, it's also we call as a shortest chain between that the source and the destination node. So if you can see, for example, so from A to B, for example, this is A to B. Oh, sorry, A, B is already there. So maybe it's a C, D, E. Okay. Okay, so we see the destination from A to B. So we need to choose that the shortest distance. Probably like say for example, this A to C. So could be that distance is shorter than the distance from A to D. Okay, so this could be say for example 6. Okay, the shortest distance we choose, which is has a shortest destination. Okay, A to C is a 4. So maybe this is probably 5. Okay, this is could be 7. All right. We compare to C to 5. Okay. So compared to this C to E. So this is the shortest distance. So we choose this. And then from here, we choose D to B. So probably maybe this is 4. And this is, say, for example, 8. Okay. So then we choose the best possible path. So A, C, D, B. Okay, so that is your shortest route. Okay, and this is what we call as a path. Okay, you see that the arrow is bolded, so that is the we assume taken as the solution. Okay, next cycle. Okay, cycle is referred to the closed path in the graph, meaning it starts and ends at the same node. Okay, if you can see that. So, for example, say this is A, B, C. So if you see that the path, the cycle is just moving from A to B and B to C and then C to A. So this we call as this path. So this is something we can explain has some problematic term of the shortest path algorithm because they can create infinite loop. Okay, so it will create that infinite loop. So that means we not really prefer that the cycles. Okay, so mainly we just only look into the nodes. Okay, we call that ages, and then the path, arcs, and so on. So based on that, we come to cycles. We will moving on that the other terms in PERT, PERT, and the CPM. Okay, critical path method. All right, this is the basic terminologies you need to know in that network analysis. So from here, we can develop that the network model. All right. Okay. Further, let's do some examples of that arc list representation. Okay. So these are given diagrams. Okay. So the diagram is from 1 to 4. So they given the direction of the path from 1 to 2 and as well 1 to 4. Okay. So the set we can illustrate in the form of the arcs, which is 1, 2. Okay, 1 and 2. So which means they represent the B. Okay. So 1, 2. And then 1, 4. Okay, the another set of arcs is given 1, 4, which is the presence of A. Okay. So this is that the set. Okay, set arc. Okay. And then the second 2 to 3. So 2 to 3. So 2 to 3. So there is only one set. There is no any other set is given in that directed graph. So it just has a only one set arc, set of arc. Okay, 3. So since the 3 is at the no other destinations given, because everything the 2 is ended up at the 3, and the 4 is ended up in the 3. So it means there is no any connections from the 3. So that means we can say that there is a null set up. Okay, null set up. So there is no arcs in that at the point 3. Okay, at the 4. So when you look at that, the 4. So we have 4, 2. You can see that the directed line, the arrow from 4 to 2. So we have one set which is represent the C, and then the another set which is 4 to 3. So we represent by the D. Okay, so this is that the set of arcs based on the given directed graph. Okay, all right, moving on. Okay, so when we come to that, the same diagram, just now we just look into the previous slide. Okay, we illustrate all the nodes. Okay, the node 1, node 2, node 3, and node 4. So based on this, so node 1, node 2, node 3, and node 4. So we can represent. So the node I points to the first arc on the arcs list to which head is node I. So that means we just choose that the which is started from. So 1, 2, we do not illustrate it because it's what the starting point. And then the 2, so we just take that the initial point, which is 2, 3. And then we have a null set at the 3. So we don't have any beginning of the first point in the arc set. So, and then the fourth node, so we have a 2. One is 4, 2. We take the smallest numbers, 4, 2. And then followed by the 4, 2. Okay, so this is how we need to illustrate all the arcs, okay, based on the given nodes point. Okay, so this is the way you need to represent. Okay, now further we can see that there's some definitions as well as representation. Okay, usually the networks. Okay, so we have a two type of that the graph. One is undirected graph. So if you can see that the line which is connected to one to another nodes, there is no any direction. Okay, you can see there is no any directions given in that the line. So this we call as a undirected graph. Okay, so which means it could be from 3 to 4 or 4 to 3. You can take either way. Okay, so it can be either way. So 3, 4. So we can say that arc set is a 3, 4, or we can also take 4, 3. Okay, for this case, for the undirected graph. Okay, and on the right hand side here, given is a directed graph. So as you know that earlier, I told you before, so the directed graph will be given a direction. So you see the 1 is directed to 4, and then 1 is directed to 2 here, and then 4 is directed to 2, 2, and then the 2 is moving to 3. Okay, as well as the 4 moving to 3. So that is the directed graph. Okay, usually in network, we denote the networks for G. Okay, and N is 10 for the nodes. Okay, node, and the A is 10 for the arc. Okay, that's the illustration we given. The node set of N usually they represent 1, 2, 3, 4. So you can see the curly bracket. Okay, curly bracket, start curly bracket. The 1, 2, 3, 4 is meaning that is indicate all the nodes involved in that the system or in the networks model. Okay, so say for example, if a 1 to 10, so then which means there is a 10 nodes in that model. Okay, now the arc set of A. Okay, the arc set of A. So A, we're going to look at the arc set. So it will illustrate all the directed arcs. Okay, the directed arcs. So 1 to 2. Okay, we have for example 1 to 2. Okay, and then 1, 3. Okay, and then 3, 2. Okay, 3, 2, and then 3, 4, 2, 4. So that means they give you all the sets of the arc set. Okay, so they list down everything out. Okay, all right. So this that the based on all the possible arcs listed down. Okay, so I just okay, the fourth one I just already explained here. Okay, this could be switch on the other way around. Okay, 3, 4 or 4, 3 or 2, 3 or 3, 2 and so on. Okay, so these are all that there's some representations which is be given for the network model. Okay, now we more go to specific on the shortest path problem. Okay, so today topics we will discuss on that shortest path problem. So we will see that what the important element we should know, we learn in order to analyze that the model. Okay, all right. The shortest path problem is a fundamental problem that aim to find that the path between the two specific nodes. That's all we need to know. Okay, so that the path between the two specific node or vertices in a network that minimize. Okay, minimize. That means we need to take that the shortest. Okay, the shortest distance, cost, time, and everything. Okay, as long as it's the minimum value we need to consider between the two nodes point or between the two vertices. Okay, all right. Now, first distance. Okay, what of those elements we need to involve? Okay, we look into that there. Try to minimize the function. First is distance. Okay, so for example, in the transportation networks, mostly we will, in order to minimize the cost, we have to look for the shortest distance. Correct, not? Okay, so usually say if the distance is longer, that means it involves some expenses, like in terms of your sources. For example, it's a petrol or diesel cost. Okay, and then you have to look into the other type of the cost. Maybe you can pay a much higher tolls compared to the shortest distance and so on. So that is one of the reasons the price of the product is increased. Okay, so if the shortest distance is as smallest, I mean the distance is minimized, then the price will be lower as possible. Okay, so that is one of the reasons we just look into that the distance. Next is the time. Okay, all right, where usually the time is involved at the social science. First is the communication networks. Okay, the communication networks. As time is the one of that the cost function, which is might represent that time takes the information to travel between the nodes. So in the if short timers, that means it's more preferable compared to that the longer time. Okay, so we're going to involve the time as well. We need to consider the time to be minimized. Of course, cost. The third is cost. So in the financial networks, mainly involved in the banking line, the services, okay, financial services. The cost function is might represents that monetary cost of that transversing of the path. Okay, of course, we're going to reduce the cost of certain things in the financial activities. So the shortest path problem is one of the essential network model in order to analyze that to minimize the. And then resources consumption. This is very important nowadays. So look at that resource consumption. So resources something like is going to be n, right, in one time, maybe in the future. Okay, so in order to avoid that, in order to find the alternative, so we need to know that how we're going to reduce the resources. Okay, so mainly is involved in that in the petroleums. Okay, like Malaysia, as you all know that Malaysia is one of the petroleum produced country. Okay, and the resources is there, but we do not know when it's going to be end. Okay, so once it's end, that's it. We will have a great impact on that economic impact in our system. So that will be affect pretty much our monetary system in Malaysia. Okay, and economy will be affected. That's come after like inflations, and we may like face economical issues like we know the uh, manpower cut, okay, and then we will find a lot of issues like consequences if that the resources wants is end. So we need to know that how to save and then minimize or reduce that the consumption of the resources. Okay, so these are the main things you need to know and analyze, okay, in the shortest path problems. Okay, now take a look at this example. Okay, all right, so the first example one is just very basic things, basic example. Okay, I give you the pictures, then how we're going to analyze the table or data, okay, or network model. Okay, how we're going to develop a network model based on that the given information. Okay, now the branches leading out of each node in the shortest path networks is given in the form of the table A to E. Okay, so each node points A, B, C, D, E. Okay, and we have an F as well. Okay, so first thing, you need to construct a list of each node in the network of the branches leading out of the nodes. So means we just look at that, the A, B. So now the A, B, okay. So we see that probably we just take that this is a distance kilometers, for example. Okay, so 250. Okay, and then A to C is about 400. Okay, and then from the B, node B, so the B is leading to C and as well as to D. So we can write that the BC. So we just give that is weightage, probably under could be in the kilometers. All right, and then to B to D, which is 10 kilometers. All right, so we just list down, and then from the node C. So node C, there is a three splits. One is C to B, C to D, and C to E, and we just write that the weightage weight respect to that each every destination. C to B is about 100 kilometers, for example, and C to D is about 150 kilometers, and C to E is about 275 kilometers. As well goes to D, okay, and as well E, okay. So we say that the direction, okay, for each every nodes, okay, from the D to E, D to C, D to F, D to B, and this all this as a weightage. Oh, weight. Okay, your weight. Okay, so all these things. All right, now second, each branch is identified by two letters symbols. First letter is nodes branch, leave from, and the second letters is a node is goes to. That means is the first node is a second nodes. Okay, where is come from node A to node B. Okay, node A to node B. That's what it means here. And then beside that, there's a symbol or the nodes. We just give the weight. Okay, so the weight of the or length of the branch. Okay, so length of the branch we call as a length, as a weight. Okay, all right. Now we're going to develop that network model. At the same time, you're going to look for the shortest distance of this entire information that we have. Okay, now so we copy that the table that we have just now, okay, in the previous slide. Step one, okay, so we're going to look for that the steps. Okay, so first you identify the branches that lead away from the origin. Okay, so for this case we can see that A to B, all right, and then A to C. So we have two branches, okay, from the nodes, which is AB and AC. Okay, and then we're going to select which of the branches is that the minimum or shortest. Okay, so now you see that AB is at 250, the length, and the AC is about 400. So we just draw a line or the model. Okay, say so this is the For example, just assume that this is in the kilometers, all right? So it's come from the node A, okay? It's moving to the node B, okay? It's a distance about 250, okay? So based on the information that we knows, and then from that node A to C, they're given about 400, okay? So compared to the 250 and the 400, so 250 is the shortest. That means we choose this path, okay? Path from A to B, okay? That's the first step, okay? So when you just considers to choose the shortest destinations, okay? That's the first, we done this. Okay, next, moving on. Step 2, we choose that the second nearest nodes to the origin. Okay, so which is those nearest to A and B. Okay, which is no close to A, those nearest to A to B. So we need to check which is closest. Okay, so now we can see that the closest is the second nearest nodes, okay, to the origin. So we can see that is a given from B to C is 100. Okay, so B to D is 300. Okay, so we just take the counts from A to B is a 250. So we already consider this path. So we take the 250. We add on with that the B to C, which is 100. Okay, so we get 350, which means this is shortest distance. Compared to AC, we cannot take OC because it's 400 is exited. Okay, AC is exited, so we cannot take this. Still, we cannot take that the AC. So now we just fix with that A to B and then B to C. Okay, the nearest nodes. Okay, moving on. Step 3, you need to choose that the third nearest nodes, which is to the origin, which is nearest to B and C. Okay, so which is nearest to B and C, you need to check which is nearest to the B and C from the D, whether 300 or 150. Okay, so for now, you can see clearly that the distance between that the B to D is given about 300 kilometers. Okay, for example, just take an example, 200 kilometers. Okay, so it's like a longest way compared to that the distance between C to D. So that means we stick to that 150. You just add on is 250 plus 100 and then plus 150. So the total distance that we know now is about 500. Okay, all right, now next. So once you're done, moving on, we're going to look for the step 4. The step 4, we're going to choose a fourth nearest route from the origin, okay, which is nearest to C and D. So C and D, C and D. So we're going to find the nearest route, okay. So we check whether from E to C or E to D, okay. So when you look at that, here is a D to E is a 100, and for the C to E is a 275. So now we just add up all that the shortest distance. So 250 plus 100, okay. So 250 plus 100 is 350, and then we add on 150, it become 500, and then 500 add on 100, it's become a 600. That means we can conclude that the shortest distance, okay, okay, sorry, 600, okay, so is 600, okay, up to this point, okay. All right, now we go further. So we choose that the last nearest point, the origin, which is nearest to D and E, okay. So which is nearest to D and E, we can choose, okay, they ended up at the 5. So we just take from the D to F is about 200 kilometers, and if compared to that E to F is just 150 kilometers, okay. So then you can obviously can see that the link between that each every one of that the shortest distance, okay, from A to B, B to C, C to D, and D to E, and E to F. So the distance that we choose is about, we add up, we just obtain 700 kilometers. Okay, so we can simplify it. Okay, we write that the path, okay, the path which is can be written as this, as follow. So the shortest path is from A to node A to node F. This can be represents by this arrow A to B, B to C, C to D, D to E, and E to F. So this is that your shortest path. Okay, shortest path. And then with the distance about 700 kilometers. Okay, so this is how we're going to analyze based on that the given table, based on example 1. Is it clear, guys? Any questions?
So far, so good.
Okay, clear? All right. Now, moving on. Okay, we look into that the equipment replacement problems. Okay, this type of question is a very famous, all right, in the shortest distance or shortest path problems. Equipment replacements. Okay, now take a look this Renka. Okay, Renka is developing a replacement policy for its car fleet for a 4 years period. Okay, so we have 4 years. Okay, year 1, year 2, year 3, year 4. Okay, all right. Now we just look at that all the information that we have in the question. At the start of each subsequent year, a decision can be made as to keep a car or to replace it. So which means they're given a decision, okay, which is whether they can keep it the car or they can replace the car on the following years. Okay, the car has to be, okay, this is a condition, the car has to be in service for at least 1 year. This is one of the essential information you should understand. The car has to be at least 1 year in service, okay, in order to make the replacement. Okay, all right, and then no more than the 3 years. Okay, so that which means is the service has to be at least 1 year, but it cannot be more than 3 years. So that is the condition you need to fulfill. Okay, now the replacement, the cost is shown in the table below. Okay, this is a replacement cost. Okay, so this is a replacement cost is given. Okay, so this is a replacement cost. Okay, as shown in the table below, as a function of the period when it is purchased and the years kept in operation. Okay, so one is actually the price of the car. Okay, so price of the car. Okay, each year when you just make the purchasement, and then this is the other operational cost. Okay, the other operational cost, which is you kept the car, so it will be as listed in the table. Okay, now your objective is, now you need to determine the best decision that minimize the total cost incurred over the period of the 4 years. Okay, so now what the systematic approach, I think in even your daily life activities, even you can see if somebody or okay, one of you have interested to just buy a car, and then all of a sudden the new car's coming in. Okay, so you decide to just sell the car and then you buy the another one. Okay, but you also must think that if you want to sell the car, so you need to bear some other causes as well. Say if you just want to keep the car, you also entitled to involve that the service cost for the car. Okay, so you have to consider all of this the causes, the cost of the items. All right, so when before they make a decision, so this is very important for you to understand, all right, to analyze when you should make the replacement of your vehicles or machines, for example. Okay, so you have a company. Okay, so you just run the machine for the certain period of times. and then the new machine is coming in, he decided to buy it. All right. So this is decision making process involve that the equipment replacement policies. Okay, as a shortest shortest path problems. Okay, it will help you a lot. Okay, now when you read this question, I'm sure you just understand what's the things you need to list down. All right, the first thing you need to write down all the possible replacement that you can make on this cars. Okay, all right. The first step, all you need to do in order to make a decision. Okay, so first thing you need to list down all that the possible that you can carry out in order to find the replacement. Okay, let's see that what the all the possible decision you can be made. Okay, say for example, the car in years going to change first year, second year, third year, and fourth year. Say for example, after 1 year you just buy another car. Okay, after you wait another years, you buy another new car. So that means you can see that the cost of car. Okay, so that is the first possible uh, decision. So then you just list down all these things here. Is a 1, 2, 3, 4, 5, 6, 7. That is a 7 possible decisions that you can carry out. Okay, now your objective is, out of these 7 possible decisions, you need to calculate that the minimum, okay, the minimum cost that you can carry out by doing or by make a decision by replacing the car. Okay, so now for each every decisions, all right, so this is the cost involved. Okay, this is the cost involved. Okay, and then you calculate that total cost, how much it is for the each decision that you take a decision. Okay, so this on the green box. Okay, now you can see the first decision you make. Okay, you buy a car. Okay, buy car in the years first year, second year, third year, and fourth year. Okay, okay. So when you buy in the first year, the price is 4,000, and then the subsequent year, you buy another new car, it's about $4,300, and then you make the subsequent years in year 3. When you purchase a car, it's a 4,800, and then at the fourth year, in the beginning of the year, when you purchase the car, it's a 4,900. So you sum up everything, the total cost involved is 18,000. Okay, so you get 18,000. Okay, that's the first possible way. Okay, now second thing is a car in year, say you just involve first year. Okay, you buy, and then second year you buy the car, and then keep the car, wait until the third year. Okay, all right, now so which is involved, first year you buy the car, and then second year, and then you just keep the car for another 2 years, so it becomes 7,100. Okay, and then you don't buy any car after that, so just put that the cost. Okay, and then you calculate all that, the operation costs and the replacement cost, everything will be 15,400. Likewise, when you buy a car in year 1, and then the second year, followed by the second year, you just keep that car, all right, and then this 2 years after, so you just find the replacement, is become a 6,200. Okay, and then the third year, okay, you don't buy any car, and then you just keep the same car. Okay, fourth year you're going to buy another new car, which is 4,900. So you total up is give you 15,100. Okay, maybe you can assume that it's in a dollar. Okay, and the decision possible, the possible decisions. Okay, another way is a 1, 3, 4. Another possible decision is 1, 2. Okay, so which means you just keep the car the first year. All right, then you keep it for some times. All right, so and then the operation cost and everything is counted up to 8,700. Okay, likewise, the car in years 1, 3 and car is year 1, 4. Okay, now, so out of all this possible value, all right, so you just calculate that the total cost. Okay, so each total cost, and then we need to choose which is the minimum. Okay, now once you've done this, okay, in the table you list down all the possible. Okay, the second thing is what all you need to do is you need to develop that the network model. Okay, in order to see that the shortest path. Okay, moving on. Okay, okay, this is a network model based on that the all the possible decisions that you made based on the 7 decisions. Okay, so okay, which means first year, okay, say you buy the first year car, and then followed by the second year, third year, fourth year, and then fifth year. Okay, the fifth year, which means, so this is we need to add on another notes. Okay, so up to this point, so if you just, because if you buy a car, right, in the fourth year, it's the beginning of the fourth year, it's the ends of that fourth year, which means year 5. Okay, that's what you need to assume that. Okay, so every year you buy a car, so you represent the first choice, 1, 2, 3, 4, and 5. Okay, so when you consider this, okay, so first year you buy the car, okay, and then second year you buy another car, and then you keep it the car, okay, for rest for the 2 years. So the 7,100 is involved, including that operational cost. Okay, operational cost, which is 7,400. Okay, 7,400. So this is your option 2. Sorry, option 3. Option 2. Option 3, 1, 2, 4. Likewise, first you choose a car. Okay, when you buy a car the first year. Okay, and then the second year you buy a car, and then but you keep it for the 2 years operations, which is cost is about 6,200. Okay, and then you buy new car on the year 4, which is 4,900. Okay, that is a third possible decision. And then likewise, and so on for the fourth decision, 135. So first year buy the 4,000s. Sorry, 4,000. The 134, which means 1, you keep it until third year, so it become a 5,400. Okay, this part. Okay, and then in the year 3, you just buy. You don't buy any car because there is no 2 there, so you don't any buy the 2 is a 3. You're going to buy another car which is for in the year 3, which is 4,800 here. Okay, 4,800, and then in the year 4 you buy another one more car which is 4,900. So the total is 15,100. Okay, the option 5 for decision 5. So you just buy a car year 1 and 2. So when you buy a car in year 1, it's a 4,000. Okay, and then you buy in year 2, but keep it for until end of year 4. Okay, so which means up to year. So all the operation cost, everything is count about 8,700. Okay, so if you calculate everything up to 12,700 altogether. Okay, now look at the option 5. So option 5, you buy a car in year 1 and 3. So first year you buy the car and then keep it until year 3. It's about 5,400, and then again you make another purchase. Okay, but you decided to just keep car until end of year 4, which is 7,100. So add them together, you get a 12,500. 12,500. Okay, all right, so that is your option 6. And last option, same things, you buy a car 1 and then you keep it up to year 4, so which is already cost about 9,800, the operational cost, and then you buy another new car with 4,900. That is all cost together 14,700. Okay, among that all the possible, the technique, possible decision that you made in order to find the replacement of the car, So the lowest is about 12,500. Okay, these are lowest. These are lowest value of it. That means the more effective, efficient, in order to find the replacement for the car will be by replace the car on the first year. You buy the first year the car, and then you keep it for 2 years, and then you make another purchase on that the 30 years, which will be give you $12,500. Okay, that means the shortest path for the effective path for this problem is a 1, 3, and 5. Okay, so this is your shortest, the best shortest path, okay, that you can consider. Okay, so which means you just only purchasing a car year 1 and year 3. That's it. Okay, that will minimizing your cost. Is it clear, guys? Is it clear?
Yeah, it's clear.
Huh?
Yes,
this is very
it's clear.
interesting. Okay, so after this, you can do the same way when you want to make any decision in your daily life activities. Okay, for example, you just say you plan to buy maybe iPhones. You're gonna do the same things. Every year the iPhone is coming in, right? So of course there may have some services and so on. So you also need to consider that other causes like operation costs, you know, the spare part, you know, maybe the accessories and everything. Okay, maybe computers, same things. Computers, okay, your motor car, cycles. Say you're buying a house, all right. So everything's involved the shortest path problem. Okay, all right, guys.